Welcome to my channel Statistic Magic. Today we are going to learn about concepts of population. So, what is population in statistics? In statistics, the term population has a specific meaning. It refers to the entire collection of individual or item we are interested in studying. While population ecology focuses on biological aspects, statistics is concerned with drawing conclusion about population based on sample data. Thus, all units in any field of inquiry constitute population. Think of it like if you want to know the average height of all students in your school, then your population is all the students in your school. But often it is too time consuming or expensive to study the entire population. So we take a smaller group called sample to make inferences about the larger population. So the key aspects of population is population parameter. Example: population mean mu, population standard deviation sigma, population variance sigma square. Second, sample, statistical inference, sampling technique, sampling distribution. Central limit theorem, confidence intervals, hypothesis testing. So, what is size of population? In statistics, population size refers to total number of individual or objects in a specific group. It is a fundamental concept used to describe and analyze various aspects of population such as its composition, distribution, and trends. Sample the number of units in a population is called population size, and the symbol n, capital N, is generally used to indicate size of population. The key points of population size is target population, sample population parameter, sample statistics, census, and sampling. Types of population size. There are two types of size of population, that is finite population and infinite population. Finite population is a population with a definite countable number of elements. This means we can in theory list and count each individual member of the population. Examples such as students in a specific university, employees in a company. An infinite population. An infinite population is a population that is theoretically limitless in size. It is a population where it is impossible to count the number of individual elements. For instance, like stars in a sky, manufacturing process, the number of items produced by machine over extended periods can be considered infinite, especially if the process is continuous. What is sampling? Sampling is the process of selecting a subset of population to estimate characteristics of the entire population. It is a fundamental technique in statistical inference, allowing researchers to draw a conclusion about a population without examining every individual. Typically, researchers and survey use samples to make educated guesses or draw conclusions about the characteristics of the larger population from which the sample were drawn. A sample size is a smaller group of selected from a larger group population. The sample size refers to a number of individuals or items in this smaller group, often denoted by small n. Examples such as public opinion polls like population all eligible voters in a country, but a sample is a random selection of 1,000 voters. The purpose is to gauge public opinion on political issues or candidate preferences. Reasons for sampling is very cost effective and time efficient method compared to studying the entire population. It can yield result faster. Like I've said, Paul Booth. Second is the trained professional conducting sample studies often lead to more accurate measurements. Third, when dealing with infinite population, sampling is the only feasible approach. If a test involves destroying the item being studied, sampling is the only option. Sampling also allows for estimating the margin of error, providing insights into population characteristics. What is random sampling? Random sampling is a statistical method used to select a subset of population in a way that ensures each member of population has equal chance of being chosen. This method helps to minimize bias and increase the representativeness of the sample. It is also known as probability sampling or representative sampling. Key characteristics of random sampling is unbiased selection. Every member of the population has the equal opportunity to be selected. 2. Representative sample. The sample is likely to reflect the characteristics of the entire population. 3. Statistical inference. The result obtained from the sample can be generalized to the population with a certain level of confidence. What is simple random sampling? Simple random sampling is a basic probability sampling technique where every member of the population has an equal chance of being selected. This method ensures unbiased selection and helps to minimize sampling error. Key points: equal probability, independence. There are two primary methods for selecting sample. Number one is sampling without replacement. That is, once a unit is selected, it's removed from the population and cannot be chosen again. And second is the sampling with replacement. After a unit is selected, it's returned to the population, allowing it to be chosen multiple times, that is, again and again. Now we will discuss further about simple random sampling with and without replacement. Like I've said, simple random sampling without replacement, that is, this method involves selecting n items from a population of capital N items one at a time without replacing any selected item back into the population. This ensures that each remaining item has an equal chance of being selected at each stage. Second, simple random sampling with replacement is a method where each item in the population has equal chance of being selected at every stage of sampling process. This means that when an item is selected, it's returned to the population and it can be selected again in subsequent draws. Statistic and parameter. In statistics, we often distinguish between two key concepts: statistics and parameter. A parameter is a numerical characteristic that describes a whole population. It's a fixed value that doesn't change, but it's often unknown. Example: population mean mu, the average value of variable for the entire population. Population standard deviation sigma, a measure of the spread of data in the population. Population proportion p, the proportion of individual in the population with specific characteristics. Now, statistics. A statistic is a numerical characteristic that describes a sample. It is calculated from sample data and is used to estimate population parameter. Examples such as sample mean x bar, the average value of the variable for a sample. Sample standard deviation S, a measure of the spread of data in a sample. Sample proportion p cap, the proportion of the individual in a sample with specific characteristics. The key difference between parameter and a statistic is parameter describes the entire population while statistics describe a sample. The goal of the statistical inference is to use sample statistics to estimate population parameter. For example, we might use the sample mean x bar to estimate the population mean mu.